Yeah, so welcome everyone. Today we are going to deal with a t-test, just like I posted on the group. And most of the research questions that we are going to address are if at all there is association between one variable and the other. That's more, we are just going to test the association, but we will not like tell to say the association is stronger. When I say association, means like the way we did with and actually we'll touch base on the chi-square test of association to see how does one variable behave as the other variable changes. Just like the correlation, you cannot tell, we can tell that there is a positive correlation, yes, but we cannot like tell how strong the association using the chi-square. But then maybe if we do like more of the lessons that we're going to come, for example, regression as well as logistic regression or linear regression, that's where we understand more of the association. We'll be talking more of risk ratio or odds ratio if you've ever heard about them. If not, then that's fine. So today we are going just to deal with the t-test. In most of the research questions that I posed there on the group was to, first of all, to see the association, and then second of all is to see the mean difference. For example, you are conducting an intervention. An intervention that you are a teacher, for example, and then you are doing an intervention where an organization has come to your school and says, well, I want to give, for example, porridge to students. Once we give porridge to students, we think that their scores or their performance would improve. And so we will be interested to see what's the mean performance in the class. For example, is 60%, for example. And so we are going to make one class receive the porridge, one class should not receive, the other class should not receive the porridge. And then we will need to test, like before situation, before they are given porridge, we're going to give them a test, and then we get the mean average of that test, for example, 60%, for example. And then they are given the porridge, and then later on, maybe like for a good period of time, then we give them another test and then try to compare, has the porridge contributed anything toward the students' performance, for example. So that's where we are trying to test the mean difference, like what was the situation before and what's the situation after. And we can also test statistically to see, for example, age group. Like age of a certain population. If you have done literature or from a written materials or research, they say, okay, the mean average of students is 60, for example, college students is 60. So we are going to see, to test that using the data that we go. So we correct, so we go to the field and then correct the data and then see if at all the mean average is 60 as Perry said, as Perry maybe the literature that has been suggested. In this situation, it means we have in this situation, it means we have we have a one sample. There I was talking of an independent sample, one sample, a paired sample, and the like. So let me try to use the data set that we have been working on together for a period of time. So I will just, wow, it's all complaining from the top. So since when did it start complaining? So the food here is okay. This one is okay. This one is okay. This one is okay. All of this one is okay, is okay, is okay. And then here it says, wow. It says there is something that I haven't used. It says unused error in select. I need not to be getting error at this point in time. Let me just use the last time data set, which was in, I think was, do not use this. Then let me just open a script from the last time. No need of, we have been handling these errors the wrong time, so I need not to debug now because we don't have much time. So let me just use the one of the script from lesson number 5. I think this one has it all. I don't know if it's going also to give me an error. Yes, it's giving me the same error. It says object wash not found. Okay. So select variables from the larger data set. Wash, select Madzi, that's Madzi, yes. So what's the problem here? Unused arguments, household ID. Okay. And gender, age respondent, age level, household level, and the like. Why is it showing this? Okay. I thought we already, okay, so let's see. I go to, I get the names of the variable code Madzi. I needed household ID. That's the way it is written, household ID. And then I also have gender respondent, yes. Age respondent, yes. Age level, yes. And then household head, yes. And total household members. So total household members, yes. And so what's the problem here?
Asandikane ndine. I don't want to be contaminated. Sabo, I'm Brian. Okay.
Okay, so it seems that I still get an error. I don't know where the error is coming from. Wow, that's interesting though. We've been learning this all over, but I haven't gotten any error. And today we have an error.
You were busy watching TV. We're busy at home watching TV. Eh?
Okay, so it looks like today was a bad luck. I changed my operating system, so maybe that has caused something that I need to debug on. Okay, so what we do is we don't use this data set. We use a certain data set. So of course we have, I will call, I know you will not be able to, data set called mass. So I'll call library code dataset mass and then attach a dataset code survey. Okay, so I'll just give it survey 1 to be, okay. Yeah, so how do we perform t-test? I need to check the data set code survey first of all. So this is the data set that is available in there. So you can do, for example, you can do view. Apologies that our data will not be until I debug that, but we don't have that much time. So if you go here, you find this data set is already like an inbuilt in the system. So you have you need just to install this library, this package called mass, and then you attach means like you call the data set, and then if you view the data set, you find that we have a data set called survey, which has sex and all of these variables. If the person is a smoker, his height, his age, and the pace. So if, for example, I do want to understand this survey data, I will remember that time I talked about. So you put a question mark, it will tell you this is the student survey data. This data contains the response of so many students, where it says sex is the sex of the student, WRHND, that's the span distance from the tip of the thumb to the and the right. And then it will give you folders in 4 which is on top. Pace, that's the pace rate of the students in beats per minute, and etc. Height, that's the height of the students. And now, for example, we want to do a t-test. In this context, we have, for example, we have a variable called height. So we want to do a t-test on this variable called height, whether we want to understand if for example, from the literature that we have reviewed, from research articles that people have written, the mean height for students is, for example, how many meters? Maybe like, I would say maybe 100 is too much. So how do we see, first of all, is we can do a summary of this height and see which one is the minimum and which one is the maximum. So that would tell us, for example, if we do that, we see the minimum was 150, and then the maximum, these are centimeters. So the minimum is 150, then the tallest guy was 200, for example. So we have read from literature, and the literature suggests that the mean average height for students is 170, for example. And then we would say, let's test from the data set that we have gotten. Let us test to see if we have like the height that we have captured is statistically different from the one that was proposed maybe in the literature, for example. So in that context, we are going to just do a t-test. So we will just do t-test. Okay, so if you put 3, for example, t.test, then that one will come, and then we need to get this data set and a variable called height. And then here we will need to include what is known as mu. So mu is, I think some of these are more statistical, but you would understand that this is the variable that we have gotten from the population or from the literature. So the literature says that the mean height of students is 170. We have collected information from students, and we want to test if our information from students matches with what is from the literature statistically. So here I will include, like, for example, 170. That's from the literature. And so if you run that test, we are going to obtain these results. As I said that time, that the interpretation might be a bit different, like we would need someone to help us interpret, but for some of these simple ones, I'll be able to interpret them. But for the time we go to like complex sort of statistics, I will need someone maybe who is like very involved in doing this kind of research, because my job right now does not involve much of doing this kind of analysis. So this one is a one sample t-test. Why is a one sample t-test? Is we have just gotten one population where we have sampled, and then we have measured the height from this population. And then we're comparing the median, or the mean height from our population to that of the literature. So you get these results like one sample t-test, and then it tells you what's the data, and then it also tells you what's the t-value, what is the degree of freedom, and then what's the p-value. So from scientific world, there is an agreement that if you find any p-value that is less than 0.01, then you would say that it is statistically significant. What does it mean here is, for example, here it says the alternative hypothesis, it says that the true mean is not equal to 170. And then it also gives you a confidence interval. So there are several confidence intervals. There's one that is pegged at 90. And then there is a famous one, which you get in more of the literatures or the books, plus the research articles that you're going to read, is the 95% confidence interval. Explaining about what confidence interval is another story that would need us more to understand. This is why I was saying that the subsequent lessons need someone at least to have some basics in statistics, just like basics in statistics, and that can help us move forward on a quicker note. And then it also gives you like a sample estimates and then the actual true mean of X. So in this context, we find that our p-value is 0.0005. So you need to understand that when you are doing, this is called inferential statistics. When you are doing inferential statistics or hypothesis testing, you have two statements. First is a claim. So the claim here is the true mean is equal to 170. So the true mean, we are assuming the one that we have gotten from the literature, because many people have carried research and are in support of that true mean that we got from the literature. So we will say, well, that's our gold standard. And therefore we are saying, okay, the gold standards is 170. So the true mean height is equal to 170. That's our, what is known as our null hypothesis or our claim. And then we want to test this claim using data. And we obtain the data, and then we run the test. And then we have, if the claim fails, then there always be an alternative hypothesis. So even in the court of law, when they say, well, this should go this way, and if not, then there should be a backup, or there should be an opposite of it. So in this context, our opposite is called alternative hypothesis. So the null hypothesis says the true mean is equal to 170. And then our alternative hypothesis says the true mean is not equal to 170. Now, when we say p-value is 0.005, in this context is less than 0.01, we reject the claim. In other way around, we reject our narrow hypothesis and support the alternative hypothesis that it is not equal to 170. So this, it's a bit confusing, yes, but well, you would be ready to maybe as we be proceeding, just I asked someone last time to help us with the interpretation, only that she's busy, as Elia said. So that's how we do the t-test, and that's the simple interpretation of the same. Now, if, for example, I want to see this simple t-test, but then in the two groups, for example, how does the height differ in males as well as females? So we have two groups. These two groups, despite that we have one sample t-test, but we have two groups that we went to compare the height. And then now it has changed to something which is called independent sample t-test. So independent sample t-test means that we are going to perform the very same t-test, but then in two groups. Like in this specifically, these groups are not dependent. I mean, sex, it's either you're a male or female. It does not depend on each other, unless maybe for those that do maybe some biological sort of, I don't know, like maybe issues to do with chromosomes and the like, if at all they depend on one another. But sex is either you're a male or female. I'm aware that there are several sexual orientation as we move, but if we stick to the biological one, it's either you are male or female. So if you want to do the test, wow, the time is running. Okay, maybe we're just going to do these two tests, and then the other ones will be shift for the upcoming sessions. And if these sessions are more profitable to what you are going to be doing, otherwise we can just perhaps resort back to the descriptive statistics and explore more of those, because they are the most commonly used in terms of the research. So that's what I have been saying in the first phase, that we were doing the one sample t-test. Now, how do we perform the sample, the one that I have just talked about, the t-test, but for the independence one? So I will do the independent sample t-test. I already did some of like the coding for this, especially for the which was in the lesson that which just failed us. Okay, so it's okay. Yeah, so we are going to use the same, but then we will just need to specify which groups. So we are going to do a t-test, but then we have to specify the group to say, okay, we have two groups. So we can do it in two ways. One of it is to use a group where we can group by using, if you remember, we used the group by and the like. But I would want not us to do that. So let's do this quickly, because time is not on our side. So if we have so independent sample t-test. So this was one sample, just for our friends who one sample t-test. So for the independent sample t-test, as I said, we have to make a group of that, and then we are going to just use t.test. Sorry. Dot test. So in this context, we are going to get a survey, and then we are going to get what? Height as well. But then we have to make this height like in both males and females. So we can first of all group them by those two, or we can just write direct using the command. But before we do that, we also need to like understand issues to do with the ecovariance. So we will need to explore what variance is. So when you have a data set, for example, you have, like in this context, we have height, which ranges from 150 to 200. Then from there, we can get statistics such as mean, median, standard deviation. Now, standard deviation is how much does one variable or one value deviate from the actual. In this context, it deviates from the normal, which is 170, or like deviates from the actual mean. So when we did this summary statistics, I realized that I haven't explained that, which will also be crucial in this context. So in our summary statistics here, the mean is 172. Now, and we need to understand the standard deviation to say is that how much does our data deviates from the mean. Now, in order for you to get to standard deviation, there is some sort of a mathematical that is applied where you get things like variance, which when you square root variance, you get a standard deviation. So that's also, I hope, for some of you that have some basics in math and mathematics and statistics, then that should like explain what a standard deviation means. So yeah, how do we do this? So we group our data by two. So how do we do the grouping? So I will say, okay, before I run that test, I should do the grouping now. So I will say, I will call this one maybe gender. Okay, gender, sex, for example, and then we will have to survey, it's my data set survey. Then I will say, if you remember this pipe, then I'll say group by, and then from that data set, I need to group by what? I need to group by, do we have sex in this data set? Yes, so with a capital S, so I will need to group by sex. After I do the group by sex, then I'll be able now to learn my sample t-test. Because I have grouped, I'm able to get what I usually need to get in that context. So, well, how do we do that? So I do the group, and then here I'll just need to do t-test, then height here, and then I'll put here sex. So like that. So if I will do that, then I'll be able to get, let me enlarge this one a little bit. So I will get what is known as wedge 2 sample t-test. So wedge 2 sample t-test, like here I'm assuming that the variance is not equal. So as you'd say here, it says the true difference in means is not equal to 0. So it means the alternative hypothesis is telling me that the difference in means is not equal to 0, while the alternative, my actual claim was that the difference, that is the difference in males, as you would see here, it will give you what's the sample estimate in males and what's the sample estimates in females. So it will give you separate, like this one and this one. And here I get my p-value to be much less than 0, because this is 2.2 e to the power negative 16. In other words, this is 0.0 up to 15, and then 2 and going forward. So which is 0.0000 up to something. Then I get my my t, which is a negative value. Maybe because I'm using the data set that is available in the system, of which I don't have much control over, and then I have the degrees of freedom. And then the interpretation here is not much different from the interpretation that we got from the first one. Only that here the interpretation is that we are comparing the means in two groups which are independent, like as I said earlier on, that the females and males are like separate. So that's how we mostly do the T statistics. And then the third one, I only have 5 minutes. And then the third one is the one that we assume for equivariance. But maybe because of time and because this is a bit hard for maybe like starters, and I have also not done much of this for some time now, my explanation might not be that much clear. So I would maybe refer you to some text where you can get. Doing it in R is not that much difficult. Everyone can do it. But for most of the inferential statistics, what is much important is, do you understand the results that you get? Can you interpret the results that you get? Can you communicate the results that you can get to fellow researchers and people who understand like statistics and etc. But doing it in R is as simple as ABC. You know, just type in and you get the results. But what is more important is how do we explain them? Similarly, from the data set, the one data set called food, for example, the one that we had, I'll just get the data set called food, for example. So I will view it, the ones that we had here. I want you to do it on your own and then try to interpret if you can. There's a, so here there is a control group, there's a district and the like. So there is amount of savings in 2012, and then there is amount of savings in 2013, for example. Now, we would say, well, in 2012, we took a baseline, for example, a baseline, and we had to collect information from all our group. Our group, it's a very same group, the savings group. And then we had to ask them, how much did you save this year? So they gave us all of those numbers. And then we said, well, let's intervene. And so we had to give them something, maybe for production sake. So they produced a lot of things. But at the end of 2013, then we would say, well, let's evaluate. Is there any difference, like from what they had as a baseline in 2012 and what they have as in 2013, the outcome after the intervention? So here, you can also do a t-test to compare the mean, what was the mean savings of 2012 and what's the mean savings of 2013? And is there a difference between these means, like for 2012 and 2013? And is it statistically significant? So our null hypothesis will be the mean value here, the mean difference is equal to 0. There is no difference. So the mean that statistically, that is, the mean that we got in 2012 is not much different with the mean that we got in 2013. Therefore, we would say there is no improvement. And our alternative hypothesis would be say, well, there is a difference. So if we run our test statistics and find that it is less than, I mean, the p-value is less than 0.005,
then we will reject our claim and conclude that there is a difference. In other way around, conclude that our intervention had made or changed something, like in terms of the survey. So because we have less than a minute, I would thank you, each one of you. Thank you for participating. I know maybe I haven't explained like to the fullest of it all. As promised earlier on, I am good at just learning it and then trying to give it to people and could do the interpretation. So if you have questions, you can always hit on my WhatsApp, because here we don't have much time to explain over this. Try to maybe hit on my WhatsApp group or post on the group, then we try to help each other on this one. Otherwise, I would thank you so much, and I should apologize to you for the confusion that I've caused. And hopefully we will going to sort it out that next lesson should start at exactly 4 and end at the agreed time. And if there are any inconveniences, this have caused, apologies for that.
Thank you.
Sure, thank you so much.
Yeah, bye.
Yeah, thanks.